This one can study changes in the specimen being observed. This sequence records the growth of naphthalene crystals, a chemical used in insecticides. Just as ice evaporates on a sunny day, so can naphthalene. Here, potassium chloride crystals grow. Crystals of different substances grow in very specific shapes. This is because the atoms forming them are laid down in highly specific lattice-like structures. The great bricklayer of the universe never mixes up architectural plans. Each layer in this potassium chloride crystal is about 1/1000th of a millimeter wide, an orderly sequence of atom on atom, the structure of the crystal predetermined by the nature of its chemistry. The atom itself is the smallest coherent material particle, the ultimate goal of our quest into nanospace.
Hello again from Nanogate. Now that we've paved the way, we can journey to that ultimate of worlds, the realm of atoms. The atom is the brick, the building block, the basic unit of all elements combining to create the material aspect of our universe. This is the periodic table of the elements. In other words, a list of each type. In 1869, the Russian chemist Dmitry Mendeleev listed the elements from the simplest and lightest, hydrogen, to the heaviest and most complex. In a true stroke of genius, he left gaps in his periodic table for elements still to be discovered. Some we know well, others not at all. Among the most familiar, oxygen, hydrogen, carbon, and the chemical symbol for gold, AU. Hydrogen, helium, lithium, beryllium, nitrogen, iron, neon. The entire material structure of the universe is made up of about 100 different elements. They, in turn, are built of atoms.
Hydrogen, hydrogen, oxygen. Two hydrogens and one oxygen come together to form a molecule. The molecule for water. Carbon, 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 carbon. Carbon may form soot or coal or diamond. Let's try looking at the larger picture. A galaxy. If atoms are building blocks, galaxies comprise the fundamental structures of the universe. Every star in every galaxy is made up of just 100 or so different elements, and elements in their turn are made up of atoms. Yet until very recently, nobody had seen an atom.
Gold, one of the heavy elements. Turning a bar into gold leaf gives us a better idea of the properties of the smallest material things. Atoms, making up each molecule of gold. A bar starts off about as thick as a wristwatch, 7 millimeters. Each time it goes through the rolling mill, it gets thinner and longer. Before this process is finished, the bar is a ribbon 15 meters long. By this time, the gold, rolled gold sheets, can be cut with scissors. At this stage, it would take 20 sheets to make a stack of gold 1 millimeter high. Next, sheets are put between pieces of paper, and the bundles sandwiched between soft leather. At this point, the gold is beaten even thinner. Even now, the process has only just begun. The sheets are cut up, bundled again, and beaten some more. To put this in perspective, a piece of gold that started as not much bigger than a man's thumbnail is now 2 meters long by 1 meter wide, the size of a single bed. In practical terms, the area of leaf that a gold beater makes depends entirely on his skill. At this point, the gold is 150 billionths of a meter thick, so thin that we can see through solid metal. We are looking right through nanospace. Even the finest craftsman cannot reduce gold leaf to fewer than about 750 layers of atoms. That is the first reason why electron microscopes have trouble spotting one among the many. It's like looking for a needle in a haystack.
Atoms, the principal entity in nanospace, as in the universe, don't easily reveal themselves. In this computer simulation, table salt is starting to dissolve in water. The orange and green balls show sodium and chlorine bondings in the salt. The small red and white ones are water molecules. We're slowing the reaction speed by a factor of perhaps a million times. Even so, atoms are in constant motion. That is the second major reason why atoms are so difficult to find. The third reason is that atoms don't have a solid surface. We refer to them as matter, but an atom is not a physical thing like a nut. Its nucleus is surrounded by a fuzzy cloud of electrons. Finding an atomic surface amounts to surveying the edge of a fog. In other words, seeing an atom involves detecting some thing on the edge of existence, moving at enormous speed and having no physical shape.
Rising to the challenge, Hatsujiro